Welcome, everybody. We're going to be working on our chapter 6 exercises this evening. And these are the three exercises we're going to address here 6-1, 6-2, and 6-4. I am turned to those pages here in the book. You will notice that 6-1 and 6-4 are multi-parters, so if you're wondering why there's so few, it's not necessarily because there's less work, it's just, all combined into like one kind of larger exercise, basically. The main goal here is to try to kind of show you how lists work with these exercises by doing some practical little things. And I think there's some really interesting nuances here. If you are already an experienced programmer, I think you'll find these fascinating, how different they are from other languages, while in many ways being the same. If you're brand new to this, maybe by mentioning the other languages, it will kind of open your eyes a little bit to those as well. Python is a really good one to learn this stuff with, because it works with these complicated structures so elegantly, quickly, and smoothly, with very simple syntax often. At times it almost seems too simple, real frankly. All right. I don't know if I had a little internet hiccup there or something, but your face is all locked up, and then they started moving really fast, and I don't know what was going on there, but hey, whatever. All right, so let's work on exercise 6-1 first. However, and I need to be smart about how I'm proceeding here. Let's get Spider up and running. I'm going to go back to using that as a tool here. I also am going to do a little bit of file management here as well. So I'm going to open up a new file explorer window. Of course, it goes to screen number 2. And inside here, I'm going to make a spot for myself to place my work. And you guys should do the same, whatever your file management paradigm is, follow through with that. I'm going to create a new folder here for unit 6, which matches my chapter number, and then all my work's going to go in that folder. But now I'm all set for it. Back here in Spider, I'm going to go ahead and close all my open tabs, and then generate a new program and do a save as. And these are kind of all our normal procedures on a weekly basis. But it's okay to repeat them. Practice makes perfect, right? All my work's going to go there. This is going to be exercise 6-1. Right, zooming in. All right, so let me go grab the instructions here. And yeah, I'm going to copy and paste those in to the IDE so I don't have to bounce back and forth. So I'm just going to put them up here. And it says, write a program that initiates a list with 10 random integers, then prints 4 lines of output containing every element at an even index, every even element, all elements in reverse order, only the first and the last. Okay, so there's a little bit of a procedure here, but if you're reading the first part of it, we want to create a list that initializes, that is initialized, or in other words, is populated right off the bat with 10 random numbers, right, first. Okay, so for those of you that followed along when I did some of the random number generation stuff, you'll remember this a little bit, but if you haven't, and then there was also an extra credit exercise. And I think I had like 4 or 5 people in here do that extra credit exercise. And so those people are also familiar with the random thing. But if we are using a random number generator, what we're really looking for here is random integers. So I don't just want to generate a random number. There's a difference, by the way. So if I use the standard random number generator, it actually generates a random number with decimal places, which can or may or may not be useful to you. We're looking specifically for integers, though. And all right, so if we're going to do that, we can't just say, hey, Python, make some random numbers, right? We actually have to import the libraries that do that. So we're going to use this statement called the from statement, which is the way that we do an import, but first we have to say what file or library are we importing this from. So we're importing this from the random library that's attached to Python. This is part of the standard libraries, but we don't include it in every program because we don't always need it, right? From that library, we are going to import the random integer generator, which is indicated like this. And if you want to label that, if you find that helpful, this is how I labeled it. I just said import the random integer generator. So now it's imported into my program and I'm free to use it whenever I want. All right. So they're indicating to us that they want 10 values. All right. I do want to have a little bit of fun with this because 10 values are fun, but like 50 or 100 are funner, because you have more data and we can make the computer do some work, right? So I'm going to do this kind of goofy thing is I'm going to create this thing called numInt, which is going to be the tool that I use to dynamically change the number of numbers that I'm processing. I'm going to start out with 10, right? But I'm going to put this little note in here, right, for myself, right? So in other words, that, how many values do we really want to process? If we want to just go with the 10 that they're talking about, we can just hard code that into our code. But if I instead create this variable, set it to 10, and then use that variable name instead in my code, then I can quickly scale up the application to a much larger number by just changing that variable. That's kind of my method to my madness, right? And real frankly, I find that kind of fun to like push it a little bit farther than what they're talking about. And I also want to show you that Python can handle it, right? And it could be 10, it could be 50, it could be a million, right? For sure. All right. So next thing that we want to do is we want to create a list that will hold all the values that we generate. And if you want to just create an empty list, a really simple way to do it is to give it a name, throw in an equal sign, and an empty set of square brackets, just like that. This creates a list with nothing in it. How do you like the simplicity of that? That's pretty slick, right? But compare that to, and I'm just not to pick on Java, but like in Java, you would say, new array, you give it a name, then you'd instantiate it and say new, and then throw parameters at it, and then it would create it, right? Yeah, it's like a whole nomenclature. Python values equal square brackets, empty, done, right? Beautiful, love it. Okay, here's another weird little tidbit. What kind of values can I throw in there? We're intending numbers, but could I put strings in there? Sure, right? Could I put floating point numbers in there? Sure. Could I put other more complicated data structures inside the list? The answer is yes. So I could have, for example, a list of lists. That's totally doable, right? Or a list of objects, once we get to that point, whatever it is, we could put it into that structure. Python doesn't care, by the way, what we put in there. Right. For the next step, now we're going to run our random number generator to add numbers to the list. Adding numbers to a list, I don't know if it sounds this way to you, but if we're going to generate a random number, that would take up one list position. We have to do it 10 times. That sounds pretty repetitive. So a loop is the logical structure to do this with, right? I could do it manually. Okay, so if you guys remember back to the Kahoot, what is a way that I can append something to a list? And actually, I'm going to say this here. Let's experiment first. At least just a little. And you don't have to do this part of it, but I just want to demonstrate to you how this stuff works. So if I right now ran this program and did the print command and just print values, can I do that? I didn't put anything. Yeah, I can totally do that. So you should try that, right? So I ran the print command and it printed out my list. It's empty. And look what it printed. Empty square brackets. All right. So if I wanted to throw something in my list, you guys remember the command from the Kahoot? If I say values dot append, that was like the add stuff to it. And then I don't know, I'll just type a number 12. Okay. So I'm going to append that value. Now run my code. Now when I print out my list, it has a 12 in it. Well, what if I want to append another value, right? So I do another append, and this time I put in a 4. Right? And then you'll see that the list will just keep growing. So one way to add stuff to a list is to simply append, and then inside the parentheses, whatever it is I'm appending, I can throw it in there. Now, in other languages, when I make an array and I start throwing integers in it, I'm stuck throwing integers into it. Really weird. Yes, Python allows you to break that rule, and I can just put in whatever and as a string, and it doesn't care. How do you like that? Okay. Insane, right? Look, if you've learned traditional programming and you see this for the first time, like the first time I encountered it, I was like, oh my God, what could I do with that? That's where my brain starts going, because you can't do this in Java. You can't do it in C#. You declare your array or list structure to have a certain type of value, and you are stuck with it. Now, when you think of, I could do like integers, floating point numbers, strings, objects, other lists that can all go in there, and it doesn't care. Wow. Okay, that's kind of the wow. Okay. All right. So the append command is generally the one that we're going to use to add values, but now we're going to do it in a loop, right? So I'm going to start by saying for I in range, right? You remember this stuff from a few weeks ago? Seeming like a month ago now. And a list always has an index value starting at 0. So we'll start at 0. So the I will correspond to the index of our list. And we're going to run that up to the end of our list. If I want 10 values, you guys remember, like, if I want to like have 10 values, I have to go one beyond the last index position. 10 values would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 would be the 10th value. So if I put in my num int variable, which takes me to 10, I will go from 0 to 9, creating 10 values. Right. And then we need a colon here at the end. Then our command inside the loop will be to append, but we're not going to append the number 12. What are we going to append instead? We are going to append a random integer. And so the command to do that, by the way, is just randint, and then inside parentheses, a starting and ending value that's possible for those integers. So for example, I might want it to go from 0 to 100. That's what I'm going to choose to do. So the values that will be created will be in that range. So every time the loop runs, it'll run 10 times. It will randomly generate a number in that range and append it to the list. All right, let's run it and see what happens. So here's the run. All right, so there it is. Looks pretty random. Let's run it again. Oops. I'm not sure what I just did there. Oh, I collapsed my code by mistake. There it is. And I'm just going to run it a few more times to show you that it indeed is generating random values. Okay. So that's step 1, right? Is to generate the random values. So initiates a list with 10 random integers, then prints 4 lines of output containing, well, now we got to process all this stuff, right? So the easy part's done. So when I'm doing like these outputs though, and I know this is really kind of goofy, and instead of like calling it let's experiment, all right, I'm going to change that up a little bit. So last time I said this, I said test print to see what happened, right? So and you can do all this like goofy stuff here. This is like really on you. This is not really a required part of the program, but you can say stuff like, okay, I'm doing a \n for a new line. I'm going to say test prints, and then maybe another new line, and then maybe some ASCII art like that, and another new line. Right, you can get really fancy with this, and then output it and see what it looks like, and then maybe do a blank line, and then okay, so whatever, you guys are like, okay, what's the point of what he's doing right now is probably what you're thinking, but there is method to my madness, right? So I'd like to show people what's in the list, right? Because here's what's going to happen. We're going to try to get these things to happen, but if you try to get these things to happen, it doesn't mean you're actually looking at your list. So then you forget what your list is, and you're not really seeing if it's working correctly because you're not seeing what's in your list. Feel what I mean by that, right? If I just run the algorithms to do the stuff that it says, I'm going to see the output, but not what fed into it to create the input, basically. So what I suggest that you do, and you can call it whatever you want, and this is what I did last time, is I did a one print statement, right? And you can just say the original list of values is this, right? And so maybe you don't need this stuff up here, but whatever. And then don't forget, you can always do what we call string interpolation, right? That's where we use the little character there, and then we insert the variable name directly into the string. Remember that? You guys remember that? Right. This is all kind of like fading knowledge now because we're at the end of the semester instead of the beginning. But yeah, a couple different ways to do it. And then, of course, just so their content isn't all jumbled together, I'm just going to run it again just so you see what the output is. So original list of values twice. Okay, do I need all that? No, I don't. But whatever you need to do for yourself to know what was originally in there, do it. I might just really truncate it down. So here's I think what I'm going to do is I'm going to boil it down to that. And then, this stuff here, hey, whatever, is a good idea for testing. But the thing that you want to like not do when you're coding, and that's not the correct format for doing a block quote in here, is it? Right. So I'm just going to, or a block comment, right? So I'm just going to comment out this stuff. And if you guys are trying to follow along with me, for shame, right? Code your own stuff. Don't copy mine. Just kidding. I'm kidding. Of course you're copying mine. Right. Whatever you need to do. But the whole point is when you're writing a program, sometimes you do what I just did, is you do little steps, and then you just make sure that part of it worked. That's all. You don't try to write the whole thing at once, because then you're going to drive yourself crazy because you don't know where the problem happened, right? So at least at this point, what I know is if I run this code, it will give me an original list of random numbers. Now I can look at it and go, aha, there's my original list, right? Okay. So that was kind of my testing section of the program. All right. Now, I'm just going to throw this out there. If you wanted, you could write this program with a main function, right? And then write sub functions to do each one of these bullet points, and then call those in and do it that way. You could do it like that. I'm not going to, by the way. I just want to write the code, right? So I'm going to do the first task, which is to display every element at an even index. So like if I look at this list, what that means is I want to, well, this is position 0. Is that even? Yeah. Right? Zero is an even number, right? So if that's 0, this is 1, this is 2. So I'd want it to print this, 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 and this, right? That's, or whatever the random version of it is, right? So I would probably think about starting here with just a regular print statement, right? And you'll notice how I'm doing this is I'm going to basically print out this snippet of text here that says, elements that are even numbers. Every element at an, oh, this is okay. That's not really quite the same thing. So I grabbed the wrong print statement. I apologize. Let's grab this one. Right. I want to do what the command says, which is that one. Elements at an even index position. Remember, when I append this to a print statement, that keeps my cursor on the same line. So it'll print that text. And then on the next line, when I do print, it will add it to the end of the line. So it'll have like kind of like this, a little title, and then the output. Right. So that's the point of this, if you don't remember. All right. So that's the beginning of the line. Now, for me to go through and find every even indexed number, is that a repetitive process? Yes. Right. And this is another really big takeaway for working with lists and tuples and all these complicated structures. Loops were built to traverse complicated structures, so I don't have to do it manually, right? So a for loop is my friend in this case for sure, and I'm going to use the same basic command they did before. So I'm going to go I in range, and now the question is, I've already determined that zero, the zero index position, is already even, so we're going to start at position 0, right? We're going to count up to what? Whatever my num int is above, right? So spell it right. So if we go from 0 to 10, we want the whole list. 10 will take us all the way up to position 9, which is the last position in the list. Yes, I know it's not even. All right. Now, if I want to output every even position, and normally when I run a loop, it would hit every position. But if I increment by 2, I don't have to do any fancy math. It's just automatically going to traverse it. And then all I really have to say is print it out to the screen, please. And so my print statement comes into play here. And I'm just going to take whatever is in values at the current index position and then also put a space after it, waiting to print the next number. So it's going to start at position 0, right? It's going to increment by 2. And it's just going to do those, just print those automatically. Pretty simple and pretty clever, I think. Right. Putting a print statement at the end to give me a blank line. Let's run it and see if it works. Here's the run. Here's the original list. Are these the elements at an even index position? 40, 14, 62, 89, and 92. Yes. You guys all good? Okay. So that's part 1.
Can
the
you
next,
I'm a little lost on the end thing. Can you repeat that? I know you told us a couple times.
okay, oh, George, simply all that end command does is when I append this, or really I'm concatenating it to a string, it means that when I'm outputting the next snippet of text, it'll stay on the same line. And in this case, there's no space in between because I didn't put one here. In this case, I put a space in between, which is how I got these. But on this one, I'm getting the text on the screen and it just sits and waits until I hit the next print command, right? And then when I get to the next full print command, which does its own blank line, that end command switches. But basically that's a way to append text to the end of a line. And, if I'm going to do a language comparison, so for example, in C#, we have a write line and we have a write.
Okay.
And in Java, we have the same thing where you can write the whole line and move to the next one, or you just write and wait for the next. Right. And that's also why I'm putting a print command at the end, is to switch it back. The next task is this one, which is display only even, and it should say numbers in the list. That's a different ask, isn't it? Right. But we can do a print statement just like the one that we did before to start it. So elements that are even numbers in the list, once again, we're adding that little end command there so we stay on the same line. Once again, it's a loop, right? Because we need to traverse that whole structure, right? So we're going to say for I in range, and we're going to go from 0, right, first position, to whatever number we've indicated. Now this time I have to check every value, right? And every time I check the value, there's no guarantee that it's even. It could be odd. So I have to run an if statement and say if the values, whatever's in the current position that we're checking, if we mod that by 2, and that's equivalent to 0, meaning it's even, right? There's no remainder, then we'll print the value. In fact, we can use the same print statement from above and the same print statement to end. So I'm just going to paste that in here like that. So we only print it if it's an even number. If it's not, we forget about it. All right, watch the run. All right, so elements that are even numbers, well, you can just look at them and go, yep, even, 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 even. Did we miss any? Nope. They count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we're good. All right, let's move on to the next piece here. Now we're going to display all the elements in reverse order. And this is kind of an interesting one because I love the syntax of how we put the loop together, and you'll see what I mean in just a second. So let's start with an output statement so they know what they're looking at, which is going to be like this. So we're going to say display elements in reverse order. Okay, it is a loop. So for this one, we're going to say for I in range. Now, where are we going to start? Okay, so now we have to think about it because we want to go backwards. Take whatever's there, and I'll think about this. I could, I know there's 10 things, so I could just start at the number 9, right? I could just hard code it. But that will blow my whole thing with this num int thing that I came up with. So I'm actually going to start at num int, and I'm going to spell that right. And then I'm going to subtract 1 from it to put me in the right spots because num int is 10, but I want to start at position 9. So it's num int minus 1. And then I want to run down to position 0. So this is a weird one because now I'm going to go from position 9 down to position 0. But with the range command, I have to go 1 beyond it, which means I have to go to minus 1 to get to 0. And I'm going backwards on top of it all. So now I also have to say minus 1 because that's what I'm incrementing, actually decrementing by. I'm decreasing it by 1 each time. So I have to say that here because it doesn't happen automatically. So that's the loop syntax. All right. There's those of you that are clever and maybe did all the reading like in depth and tried some of the exercises like you should, right? Also recognize, could I start with minus 1? Could I have used that in the first character position? Would that have worked? You guys remember if I wanted the last item in the list, I used the minus 1. Would that work here? Yeah, some people are nodding. The answer is no, by the way. That would not work. But you could try it. You want to try it? Go for it. Okay. So now we're just printing them backwards. You know what? We can use the same print statement. We don't need to do an if or anything like that. We just put it in there. We're just going backwards. That's all. And then we want to come out and just do a regular print statement to move to the next line. All right, let's try it. See if it works. There's the run. All right, original list. 89, 13, 62, yada, 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 69. Yep, looks good. There's a reversed list. All right. The last command that we have to worry about in here is kind of an interesting one because the way that it's stated, and I want you to think about this a little bit first before you maybe necessarily answer it either in your own head or out loud here in the session. This command is to display the first and the last element. Okay, so I hope your brain goes, oh, I think that's a piece of cake, right? I don't have to loop. I don't have to do math. I don't have to do any of that. In fact, how would I display the first element? Values square bracket 0, maybe. You think that would work? Yeah, that would totally work. So for example, let's start with what I'll call kind of the traditional, I'm actually going to type this out just for the sake of typing fortitude here. I'm going to use a print statement. I am going to use string interpolation. So I'm putting the character F in there. That's how we do it in Python. And then I'm going to say first and last items. And then since I'm doing string interpolation, I'm using my curly brackets, right? And inside the curly brackets, I'm going to grab values, position 0. That's the first item right there. No magic needed on that one. Just grab the first item in the list and put it on the screen. Then I want to put in the last item, which we know is going to be part of values, and we know we have to use square brackets to access the contents. But what could I do here to get to the last position? Last position is position 9. Well, I can think of at least 3 ways to do it. So here's the first. I could take my num int. This is the dynamic one, by the way, right? So if I change num int above, this will still work, and just subtract 1 from it. Whatever, if I put in a million, it will subtract 1. If I put in 10, subtracts 1, puts me at the last position, because with 10, last position is 9. 10 minus 1 is 9, so we're all good. There's one approach. All right. Shall we prove that it works? Let's do it. Here's the run. First item 89, last item 67. Correct. All right. Here's an alternative approach. All right. And traditional programmers, mostly those with other language skills, right, will think of this approach. And this is totally works, right? So instead, to get the last position, I could just take the length of values and subtract 1 from it. Okay. Does that work? Yep. Works also. Or that clever little trick that we saw in the Kahoot, which I initially had extreme resistance to using, right? Because, when you're trained in another approach and you see a new approach, you don't want to let go of the old approach because you feel like you're going to lose that skill or something. And that's not the reality of it. Using the -1 approach actually does work. It does give you the last position when you use it inside of square brackets like that. So that approach works as well. And, if you're trying to type fast, which one do you go for? Right. Yeah, you go for the last one. All right, so that's the first exercise, folks. So every even index, only even numbers, all elements reversed, and then first and last. All right, want to have a little fun with it? Okay, so here's the fun part. I'm going to call this optional. You could process 10 numbers, or you could process 50, right? So run it, right? Just get longer lists. Can we assume that the output is still good? We should be able to, right? What if I wanted to ramp this up to 500? You can do that too. I do want you to notice how quickly it goes. Right. What if I wanted to do 50,000? Right. And this is where it gets fun, right? When you start pushing the bounds, or you think you are. Okay. Still worked. But at least you got to watch it type out the text, right? All right. 500,000. Here we go. And you guys are going, no. because I'm gonna have to sit here and watch it for 10 times as long as the previous one. But kind of neat. It kind of looks like a hacker screen in a movie or something. It just keeps like you know, does not compute or whatever, but here it is just generating lists. It doesn't even care how big it is. It's just doing it.
If it was only ones and zeros, I'd say the Matrix.
Well, I'll tell you what, could I make that happen? Yeah, really. How would I make that happen? I just change my random number generator, get rid of these two zeros right there, and it's generating nothing but ones and zeros. Put it on a green screen, and oh my God, we're halfway to the Matrix. We'll be taking the red pill, right? Pill? I don't know, follow the white rabbit, something like that. But I think it's just astounding. I want you to notice that it is really going. And 500,000 random numbers and then all processed, and it still worked. It just took a little while. So have fun with it, but just be mindful if you exceed that value, like every time you add a zero, it's 10 times as long, right? So however long that took, if you go up to 5 million, where you'd be waiting 10 times longer. All right. So let's move on to the next exercise then. All right. So let's call this one done. And let's create a new one. This is going to be exercise 6.2, I believe. All right. So let's do our save as. And I'm just going to use my standard naming convention here. Exercise 6.2. Let's go get the instructions. And this one says, write a program that reads numbers, meaning user input, I'm guessing, right? Maybe, I don't know. We'll see. Then adds them to a list if they aren't already contained in the list. When the list contains 10 numbers, the program displays the contents and quits. Okay, that sounds pretty simple. Let's paste those instructions into our new program here. So I'm just pasting them in. And let's zoom in over there a little bit so we can see it. All right. And last time I did this, I realized that really what this program is doing is this. It's building a list of 10 unique values, right? So if it's already in the list, it's not going to let it happen. And yes, I could hard code the number 10, right? But I always consider it kind of a bad practice. So I'm coming up with a variable called number of numbers, right? And I'm going to set that to 10, right? And because by doing this approach, we also can try bigger values after we get it to work to see how fun it is to make a choke, right? Or how long it takes to generate an even. So think about this, right? Like if we're getting 10 different values typed into a list, how long would it take to do like 100,000 of them? Interesting. These are really geeky questions, by the way. All right. All right. So this is what I had written as notes before. It says, read a collection of values from the user, adding each to the list if it is not already present, right? So that's kind of the command, right? And I'm trying to make my window a little wider here, and I'm not sure why it's not complying. Okay, it's just not complying. All right, I must be making my machine think about itself or something. Let's go ahead and create an empty list. So we'll just use the same name we used before. That's fine. There's our empty list. And then we're going to actually prompt the user to enter a number. Are we going to make them enter an integer, or are we going to make them enter a floating point number? Because you know what, if I ask them to enter a number, they're not necessarily confined. Like, what if they type in 3.5 instead of 4, So I'm going to prompt them for a floating point number. And so like a really simple prompt might look like this, x equals float, because I'm going to convert to float, And then inside there, we'll do an input statement. And then I'm just going to prompt them and actually that should be inside there and just say enter number. I don't care if it's a county number. I don't care what it is. Just give me a number. That's the prompt. However, we got to do this 10 times. This is a repeating thing. All right. So why don't I put that inside of a while loop? But what's going to be the thing that triggers a while loop to run? I put in the number of numbers above. So I want it to loop at least until it gets up to 10. So how about while the length of values, is less than the number of numbers that I've declared, which for now is 10, but could dynamically change to something else. So you might have hard coded 10 there. So every time the loop runs, I'm going to prompt them, right? Hopefully they type in a unique number. All right. Now, when do we want to add the numbers in? When the number is not already part of the list. So I'm going to write an if statement. I'm going to say if X, watch this clever syntax, not in values. How about that for clever syntax? So I'm saying here that the value of X, whatever it happens to be currently, is not already contained somewhere in the list of values. Then I will append it to the list. So I'm going to say values.append. And what am I appending? I'm appending X. That's just getting added, but only if it's not already in the list. Okay. Are there any other things I need to do inside this loop? Nope. All it takes to put it on the screen, believe it or not. All right, so then we would need logically to display the values on the screen. And we can do that really simply with just a very simple print statement. You can even borrow it from the previous program, right? Because we're using the same names, right? And we can say the numbers entered are, and just put it on the screen. All right. Seems too easy, doesn't it? That's kind of the whole program. And the fact that I could have hard coded this part, just put the number 10 here, I'd be done. You know, really, really short program. Very short program to do what we're being asked to do. All right, let's run this and we'll enter a number. So let's just do it really basic, like 1, 2, 3, 4, 5, 6, 7, 7, 7, 7, right? Well, 7 shouldn't go in. 8, 9, 10. Okay, so notice it converted them all to floats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 was only listed once. It seems to be working okay. All right. And now if I want to make the list bigger, I could do that. Do you want to sit there? Like, for example, if you set this to 10,000, I just want you guys to think about this for a second. Don't do that because then you have to type numbers 10,000 times to make it work to see if it works. So don't do that. Right. I don't know. And you know what? I have a little note here. Last time I was kind of playing and I'm just throwing this as kind of auxiliary info. Like for example, right? Because we haven't played with any tuples so far, have we? What if, right? Right. If I set up a tuple instead and call it values 2, and then inside a set of parentheses, put in, I don't know, 3 numbers, right? can I just output it the same way? Well, now I have to type numbers still. The bottom line is I want to show you that like putting values in a tuple and outputting is really simple. And notice when you output it that it puts the parentheses in there so you know it's a tuple. All right, so that's just a super simple example. All right, let's move on to the last exercise. We have plenty of time, but the next one is a multi-parter. So let's do a save as, and then this exercise number is exercise 4. So exercise 6_4. Let's go get the instructions on this again. Oh, wow, there's a bunch of them. Great, right? I actually have to read the instructions too. All right, here's what I'm going to do. I'm going to be lazy and grab them all, and then I'm going to read them over in my IDE so I don't have to come back here. All right, so let's go over here, and I'm just pasting those instructions right there. We should probably word wrap this. Now let's forget how to do it in here. Preferences. Oh, it's already okay. It's already set for it. I just need to zoom in. There we go. That's a lot of instructions, but let's read through them here. It says write a list of functions that carry out the following tasks for a list of integers. For each function, provide a test program. Okay, so you guys picking up on the difference here? Here we are going to create a main method, and we're going to create functions to do each one of the tasks, and then call the functions to do the tasks on top of all the other stuff that we're doing. Right, so this kind of combining skills a little bit. All right. Let's orchestrate that first. So let's orchestrate the fact that we're going to write a program that's going to have a main method. And so we're going to define main like so, right? So the main method will steer the program and run the functions, basically. So I'm just putting that there. And so I don't forget, because sometimes I do, I'm going to make sure that I type in a call to the main method at the very bottom. So I make sure it runs, right? Very often people do forget this, by the way, which is why I make a point of throwing it in. All right. All right. So next thing, it says write a list of integers. Okay. So now here it's telling us we need a list of integers. All right. They didn't tell me to ask the user for integers or to randomly generate them. They didn't give me any of that, right? So how about I define a list of integers and I don't put them inside my main method. I'm going to put them here above the main method in basically the global program space so that all the functions can access these lists. And you know what? So I'm going to define a list of numbers and I'm going to use this really goofy approach I used last time, which just makes sense to me, right? So I'm just going to create a list of numbers that goes from 1 to 10. Okay. They didn't specify what it had to be. So I'm just doing it really simple. All right. And you know what? I might play a little bit. So I'm just going to do this up front because there are some circumstances where I don't need an even numbered of entries. So I'm creating a separate list called 1 through 9. And then just to kind of make an example, and John, I'm going to have you, or Martin, I'm going to have you look at this because last time I did it, I demonstrated with a tuple also. And look at how I named it. How do you like that? With capital letters because it's a tuple. Right. So our brains are not dissimilarly thinking. Right. but also so that's more evident. But these are going to be my data sets. And once again, these will be available to all the functions in the program. Why? Because they're in the global space. They're all the way to the left margin. They're not part of any of the other functions, but now I can call them in. So why don't we start by doing something really simple like this. And I'm just going to paste this stuff in, by the way, because I have it ready to go. I'm going to display the original list of numbers, and I'll do the 1 through 10 and with the tuple, right? So the original list and the original tuple. And you know what? Let's run it right now and see if it works. So here's the run. There's the original list. There's the original tuple. It's working. And it proves that the function and the stuff inside the function is able to access these lists, which are on the global level. All right. Now let's try to do the tasks. So the tasks are swap the first and last element in the list. So I'm just going to copy this to describe what I'm doing here. And I'm just going to put it in the form of a comment. And I'm going to run it from the main method. But I need to basically take the values and put them somewhere. Now, here's a couple of things that I want you to think about here. And this gets into, once again, a little bit into the theoretical about how this stuff works. I already have the lists created. And I want to go in here and I want to take the first thing. So for example, this is my original list here, right? I want to take the first element, the 1, and switch it with the number 10. And then leave everything else in place. And then just do that, right? Here's the challenge though. When I'm doing this, after I'm done, the original list is changed, right? Then it makes it hard to track the changes that I'm going to do in the other functions, by the way. So I guess my point is that what I'm going to do here is whenever I'm working with a list to manipulate it, I'm going to make a copy of the list. This is really goofy, but I'm just going to create a variable called data that's going to hold the copy. And what I'm going to do is I'm going to use the list function to take my original 110 list and put it in data. And here's the weird theoretical part. I could also just do this. And some of you might already be thinking it. So I can take my list and copy it into another list called data like this. But here's the weird thing that happens in Python. And this is all about how memory and computers work. If I make a copy of the original list in memory, and then I change the data in the copy, it's pointing to the same memory locations, and therefore will change the original list as well, which I don't want to happen. So instead, right, if you guys are wondering why I'm doing this, I run the list command around my original list, which is a list already, but it forces it to become a separate list. Isn't that interesting? Yeah, I think that's really bizarre. This is all about how memory works on a computer. Yeah, and if you want, like, so for example, and I'm going to just put this in, right, as a note here, and I think it's probably a helpful note. So I could do it like that, right, the way I just talked about. But if I change the data, then 110 also changes, so not recommended, right? So this does not work well if you don't want to pollute your original data. And then now think about the tuple and why tuples make sense sometimes for processing, right? Because you don't want to change your data. All right. Now, I do want to create a function down here, right, that I'm going to call. So let's go to that part. So I'm going to define a function and I'm going to call it swap first. And I'm looking at what I called it last time. First, last makes sense, right? Swap the first and the last thing. And then when I create that function, do I need to send information to it? And yes, what am I sending to it? Well, I'm going to send the data, right? And so the data that I'm sending will be referred to inside the function as the data. And I want to make it really clear that this variable is actually discrete from this variable. And in any other language, I would not name my argument the same as the data from where it's being called from. But Python doesn't care. Right. So I say that really quietly like that. That doesn't care. And the truth is, I can do this in Java and C#, but it's not recommended. In Python, it's more the convention than the anomaly, which I think is really weird. Right now, we got to think about the maneuvers we have to make. So I'm taking my list, making a copy of it, putting it here, but then I want to call it and send it to this function. So let's do the function call now that I have the ability to do it. So I'm just going to say swap first last with the data being sent to it. I'm just going to execute that command. And then after that command is executed, then I would output the result to the screen, and I can just do that already up here, right? But now I have to think about the maneuvers I have to make that happen in the function. So this is where it gets a little bit weird. So I'm receiving this list, right? And I want to swap the first and the last elements. And I want to have you think about how you would do this, right? So given the fact that I'm working on a list, right? And I'm going to try to zoom in here as best as I can, right? Let's say I'm working on this list here and I want to swap 1 with 10, right? So I could grab the 1 and then just assign it to the last position, right? And then I could take the last position and assign it to the first position. But wait a second, I can't because I just put the other value in there and destroyed it. You see the conundrum here? So in order to copy this one to here and that one to here, I got to save one of them somewhere else temporarily while I do it. So that's what I'm going to do. So I'm just going to create a variable called temp. And what am I going to put in there? I'm going to take that first position, that first value, which is whatever's in my data list in position 0. I'm going to put it in a temporary holding spot. Then I can take the value that's in the last position, right? And how do I say that? And put it in the first. Could I just do -1? Yeah, you can totally do it like this. Or, right, if you want the alternative, just so you have like record of it, that's the alternative, right? This is the old school way to do it. Take the length of it, subtract 1, and that'll give us the last position. But this is basically saying take what's in the last position, put it in the first. The first position stored in a temporary spot. So now all I have to do is complete the process, right? And say the data in the last position will now get the temp data that I set aside. So there's the maneuver. Take the first thing, put it in a temporary holding spot, take the last thing, put it in place of the first, right? Take the temporary thing and put it in place of the last. All right, can we test it? Right, and that's how we're going to do this. We're going to write each function, we're going to run it and test it and prove that it works. So here's the run. Right? We know what the original values are. After we swap the first and the last, the 10's here, the 1's here, everything in between is still in order. Right? And then if you want to double check, you could always output 1 through 10 again to prove that it didn't change. Right? And if you're not sure, right here's the run, right? The original one has not changed after that happened. If I use this approach here, it would 1 through 10 would have changed. Very, very weird. It's all about memory referencing. It's a strange phenomenon, but it is a thing. All right. Now, the other thing that might be helpful, since we're going to write a whole bunch of functions that we're going to use here, is you might want to do something goofy like this, like the main thing is up above, right? And then all my function definitions are below, and I'm just going to start listing them one by one, but I'm going to steer it all from up here, right? So the next task that we have is this one. So I'm going to just paste it in. Shift all the elements by one to the right and move the last element into the first position. So the different maneuver. So we're going to take, in other words, I'm going to take the 1 and put it here, the 2 and put it here, and the 3 and put it here. They're all going to shift one position over. All right, but wait. If I move the 1 to the 2 is destroyed. Right? So I have to start at the other end if I'm moving it to the right. So in other words, I got to pull the 10 out, put it somewhere else temporarily, right? Then move the 9, then move the 8. You see what I see the maneuver? So on and so forth. And then after the 1's been moved to where the 2 is, then the 10 can come out of the temp spot and put it in the 1 spot. Why you would need to do this, I have no idea, but you know, it's kind of like your teacher saying, go to the end of the line. This is kind of what we're doing. All right, so let's think about the maneuvers there. First of all, we are going to need to make a copy of the data. So I'm just going to do that again, right? Because data has been messed up. So we're just going to overwrite it. And then I'm going to come up with a name for it, and I'm going to call it shift right. And what am I doing it with? Data. I have not defined it yet, so it's throwing an error, but I'm going to. So, and then I'm just going to have a little statement that says, after shifting right, this is what the data looks like. Okay, so now I got to define this. And here's the clever part of this. I'm just going to copy that, come down here. I'm going to type a def, paste that in, and a colon. And now let's do the maneuver. So I already mentioned that the first maneuver is to take that last position and store it somewhere. So let's just make a variable called last. And then what will we put in there? The data in the last position, data -1. There it is. Now, the process of moving everything is mechanical and repetitive, and it works backwards. So we're going to run a loop that counts down and goes backwards through the structure to move everything to the right. So watch the cleverness of this, I think. All right, so for I in range, and we're going to start at the end. So I'm going to take the length of data -1. I'm going to go down. Well, normally I'd go to position 0 if I want to count all the way down, which would mean the second character's got to be a -1. Remember from the last one, right? But I don't want to go that far because the first character is going to get moved. So I only need to go to position 0, which is the second last one in the reverse order, if you guys catch that. And we're going backwards, so it's -1. There's the for loop structure. Then from there, we're basically going to take whatever position we're in currently, because we're counting down. So I'm going to say data I is now going to be populated with whatever is in that position -1 to the left. So in other words, this position, the one I'm starting at, right? This is position 9, length of data -1, is now going to subtract 1. So we're going to go to position 8 to grab that value to put in this position. That's what we're doing with that simple syntax. Love it. So simple. And then finally, we still got to move that last piece of data in, right? So I have to say that data position 0, the first position, is now populated with whatever the last number was, and we're done. Pretty simple, right? I think. All right, let's run it. Here comes the run. Did it work? Yeah, it sure did. And, I think my console is locking up a little bit here. I just went through the process of zooming in on it, and it choked on that because of those 500,000 numbers in there. Might be a good time to restart your console, by the way. Did you know that you guys can do that? You can come up here and you can hit the little stop button, right? All right. Anyhow, let's just keep moving along here because we got a bunch more to do and not a lot of time. Kind of our standard operating paradigm. All right, next command is this one. So I'm going to start picking up the pace here a little bit. I do want you guys to remember that I have released the solutions from previous semesters, and this one will be out on, on YouTube tomorrow. All right, so with this one, we want to replace all the even elements with 0. Once again, we make a copy of the list. We calling a function we haven't created yet, but we're going to copy that name to create it. And then we're going to output the results. So we're going to create a new function called replace even. So I'm going to create some space here. Here's my def, place even, and don't forget your colon. And then now we have to think about the maneuvers that happen to do that. So how do we figure out if we're replacing the even numbers? So what we're going to replace 2, 4, 6, 8, and 10. And what are we replacing them with? With 0, right? So we have to traverse the whole list, right? So you could just set up your for loop like this. So we're going to go for I in range from 0 to the length of data. That would drop a 10 in here, which takes us to position 9. Right, you see how I'm like kind of mixing up the techniques. All right, then we just asked a very simple question. If the data in position I, right, we're just checking to see if it's even. We know how to do this. We mod it by 2. And if that happens to equal 0, then we know it's even. And then in that situation, if I can even type this here, then what we'll do is we'll take the data in position I, the current position, and we'll replace it with 0. Very, very simple. Here comes the run. Notice the zeros in place of even numbers. All right. Next command is this one. Replace each element except the first and the last by the larger of its 2 neighbors. Weird. Okay. So we're going to leave basically the 1 and the 10 alone, but the 2 will be replaced by the larger of its 2 neighbors, which is the 3, right? And then the 3 will get replaced by the 4 and so on, right? So you guys see the algorithm there? All right, so once again, we'll make a copy of the list for processing. We're going to call a function we don't have yet, but we're about to create it. And then we're going to output it to the screen. All right, so coming down here to define it. I should have typed that first, but I didn't. So there you go. All right. Once again, you got to think of the algorithm here, right? Are we traversing the whole structure? No, we're not. We're starting at position 1 and we're going 1 short of where we normally would go, which usually is handled by the range command pretty elegantly. So we're going to start at position 1 and go normally to the length of data, which should take us to position 9, but we don't want to go to that position. We're going to go to position 8 is what that's telling us. All right. And then what's the maneuver? Okay, so the data in the current position Well, I could do an if statement and all that kind of goofy stuff, but you could also use a function. And this is one that you might not see immediately. I can just use the max function and I can just look at the data in the position before the one I'm in. And then I can look at the data in the position after the one I'm in and just take the largest one, which we know is always going to be the one on the right. But hey, whatever. That algorithm works. And it does what we're asked to do, more importantly. All right, so let's go ahead and run this. All right. So is that working correctly? Yes, it is. It's weird, but it's working. I'm not really sure what the functionality of that would be. All right, next command. So I'm coming back up here to the main method. Here's the next thing. Remove the middle element if the length is odd, or the middle two elements if the length is even. Okay, now you'll understand why, by the way, I created a 1 through 9 and a 1 through 10. So how do I test it if I only have an even numbered list length, right? So I created a 1 through 9 to have an odd numbered one to test it with. That's really the why. So if that's what I'm doing, then I need to make 2 copies of the data, right? So I'm doing data 1 and data 2, right? One's a list of 1 through 10, one's a copy of list 1 through 9, right? And then I'm going to send them both to the same function, which I'm going to call remove middle. Haven't created it yet, so it's flagging an error, right? And then I'm going to output the results of each after I'm done so I can see if it worked. But now let's go make this function here called remove middle. So I'm going to scroll down. And I know I'm moving kind of quick here, but we are running rapidly out of time. So I'm trying to be mindful of that. So at least get all the solutions here. And I'm going to do a def. I am going to call this by a generic name of data. Why? Because that's what I've been doing all along. So that's what I'm doing. And all right. So here's where we might need to step away from the loop idea a little bit, right? Because I can figure out where the middle of the list is by simply doing some simple math, right? So if the length of something is 10, how do I find the middle number? Well, about divide by 2, right? Right. Yeah, that would sort of give us the middle number. But what if I divide by 2 and it's an odd numbered list? So in other words, right? And maybe this is kind of good to do here. And you know what? Here's where I want to kind of do the 1 through 9 thing so we can look at it. So I'm actually going to duplicate this and say, let's output 1 through 9. Right, I'm just going to run it as is. Oh, yeah, that's right, because I didn't finish my code. All right. But now I can look at this and see if this is of length 9 and I divide that by 2, I get 4.5. And actually with integer division, it'd give me 4. So where's the middle number? Is this the middle number? Yeah.
So divide by 2 plus 1.
Divide by 2 plus 1. All right. I'm going to have you think about this logic, but Alex, I like your thinking, right? You're kind of in the right range. So check out what I do here. I'm going to say, if the length of data mod 2, so we're dividing by 2, right? And we're looking for a remainder of 1, right? So I don't really have to add, right? So if the length of data mod 1, this handles the odd length string, I want to remove the middle item. Which is the middle item if my list is 1 through 9, right? And I can kind of use I guess I can kind of use one of these, right? So just ignore the 10, right? And what's the position number of that 5 if this is our list? What 0, 1, 2, 3, 4.
Or
Right. So what am I popping? I'm going to use the pop command to pull it out because I can pull it out right from the middle with the pop command. I'm basically going to take the pop command and feed in a position, but I got to calculate that position. And the calculation is as follows. I take the length of data and I do my integer division of 2, which omits the remainder. See how this is clever? And gives me the answer of 4, which is the correct position number to pop it. Yeah, kind of clever, I think, right? And maybe a little less code than maybe you thought, right? Otherwise, we have to remove the 2 middle items. So in a list of 10, I have to remove position 4 and 5. Okay, now watch how we do this. I'm going to do it the exact same way. Because we already know that's going to remove position 4, right? Right. After position 4 is removed, and I run the same command again, which position is it going to remove? 5 is now in position 4. See the cleverness of this one? Yeah, it's just going to keep hitting that same middle spot every time. Watch this one. This one, I like the cleverness of that. So it says after removing the middle elements. So for the first one, 5 and 6 are gone. For the second one, which is the 9 one, the 5 is gone. So it does work. All right, I think we have one more left to do. Just in the nick of time. We got 2 minutes left. Oh boy. All right, so I'm going to copy my instructions here, which are as follows. Move all the even elements to the front, otherwise preserving the order of the elements. Whew, that sounds like a hard one, right? So here's the data copy, call to the function I haven't made yet, and the output statement to see the results. Let's go make that function. It's going to be called even to the front. Pasting that in, put in a little def here and a colon at the end. All right, now a little bit of thinking involved, right? So I'm going to need to keep track now of all the positions of things. So this is kind of weird, right? So I'm going to have a position I'm tracking for the odd numbers, and then a position I'm tracking for the even numbers. And then can I do it all with one statement? Yeah, this is kind of weird. Now, we need to check each value. All right, in this case, we have numbers that are sequential, so it's really easy kind of to think about it. But maybe they're not sequential. Maybe this is a weird set of data. And that could make it a lot more random. So I'm going to create one variable called position. This is going to track the odd numbered position. I'm setting it to 0. And I'm creating one for the even position. And I'm calling it even pos, also set to 0. Then I'm going to run a while loop. And what I'm going to do is, as long as the position is less than the length of the data, I'm going to run the following loop. Let's get a colon in there. All right, so every time it runs, I'm going to check if the data in the current position, if I mod that by 2, right, this is our usual even check, right, and the remainder is 0, then we're going to take that piece of information, store it in a temporary variable after we've popped it. So we're going to remove it from the list, from the position that we're iterating through, and put it in the temporary variable just for a moment, but it's out of the list, right? Now that it's out of the list, I need to put it back in the list. And then here's the command that goes, that I guess we didn't talk about in the Kahoot, but I can insert something into a particular position so I can name what the position is. And the even position is currently 0. So it's going to go to the front of the list. And then what am I putting in there? So this is the position it's going to. This is the value that's being put there. So I'm taking the value I grabbed temporarily that I removed from the list. Now I'm moving it back to the beginning of the list through an insert command, which is kind of the tandem to pop, by the way. That's the push command in Python. And then we'll take the even position, because that's what's keeping track of where we're at, and we're incrementing it by 1. Right. And then also, once that if statement is done, I'm going to come back 1 level here, and then I'm going to take the regular position and also increment that by 1, because that's going to increment even if it's not even. And that's the whole logic, folks. This will make all of that happen. Pretty simplistic, but crazy powerful, right? I'll leave that up on the screen for a second. You guys can screen copy it, capture it, whatever. But I'm going to go run it. Let's see if it worked. 2468 13579. It worked. Right. Now, these are really easy lists, by the way, to manipulate, because we set them up so they're in order. So when we make all the maneuvers, we know that all the stuff is working. And there's a little bit of a tip that goes with that. And the tip is, when you're building functions or applications to do complicated work, that sometimes you use simplistic data sets to test to see if the work is working. And then I'm pretty confident I could throw any list of numbers at this now and have it do the same actions and have it be correct, right? But I started with something simple, and then, yeah, you could just, whatever list you can generate or enter, you could throw in. If you want to goof around with this a little bit, one thing that you could do is here, where we're taking a list and converting it to a list to make a copy of the list. You could also just feed in the tuple to the list, that kind of thing. You can put the list, you put your tuple inside there. That would work too, right? The tuple couldn't be changed though. Like if I try to feed a tuple into one of these, it wouldn't work because the contents are immutable. So I can't move anything. But I could read the tuple information, put it in a list, then play with that. That's allowable. All right, folks, that caps the evening here. So this recording is over.